Okay, so starting with the actual steps. So how to multiply rational expressions. So this is very similar to how to simplify rational expressions. There's just basically one extra step, and that is step 4. So step 1, factor. 2, determine the domain. 3, cancel things out. 4, multiply together what remains. So that's the extra step for multiplying. And then 5, give the domain based off of what you canceled out. So it's just one extra step from simplifying rational expressions. Dividing rational expressions is basically the same thing, but just one additional step on top of that. So you can see that we're just progressing step by step by step. So the extra step from dividing that's different from multiplication is step 1. Flip the rational expression that is after the division sign and turn the division sign into multiplication. So if you remember anything back to elementary school, and when you divide by a fraction, you multiply by the reciprocal. That's what we're doing here. We're taking the reciprocal and then turning it into multiplication. And then from there, you follow the steps for multiplication. So I've got a few examples here, and I'm not going to go through most of the factoring steps, so that's something that you can do on your own to verify the factoring, to make sure you do whatever method you do and you get the same answers. I do want to say though, if you need to show all those factoring steps, I would recommend organizing it and do the factoring separately from everything else in the problem. So maybe have a section that says like first fraction top, first fraction bottom, and then factor those two parts, or second fraction top, second fraction bottom, or left top, left bottom, right top, right bottom. Some way to indicate the 4 different parts that you have to factor, just to keep that organized. I try, because I'm good at factoring, because I've done this for years, I generally do the factoring in my head and then go to the next step. But you guys are not at that point, so I recommend doing that off to the side. And then once you get your factored steps, writing your answers underneath the problem you're given. So here, these are all problems. These are trinomials without any coefficient in front of the t squared, which means that these are easy to do by guessing and checking. So I'm going to factor the top left, and since I have a t squared, I know I'm going to have, a t times a t. And I'm looking for 2 numbers that multiply to -6 and add to -1. And that would be -3, +2. That's, when you do a lot of factoring, you will actually basically memorize those kind of things, because you'll see, oh, I know how this factors. You'll see it often enough. In the denominator, 2 numbers that multiply to 9 and add to 6. And this is one of our special trinomials, where you get the square of a binomial, t plus 3 squared. Now I prefer to write it twice because that makes it easier when you're doing the canceling out. Second fraction, t plus 3, doesn't need to be factored, and I'm going to just put that in parentheses so that you can see that that is grouped together. And then we have t squared minus 4, so that's a difference of 2 squares, and that factors to t minus 2, t plus 2. So once you factor, your first step is to factor, step 2 is to do the domain, and that's based off of the denominator out of each of these factors, or each of these fractions. So the first fraction, I had the same thing in the denominator, that's t plus 3, so that cannot equal 0. So if I subtract 3 from both sides, that tells me t cannot be -3. Second fraction, I've got t minus 2 and t plus 2. So t minus 2 cannot equal to 0, and when you add 2, that gives you t can't be 2. And then t plus 2 is not equal to 0, which gives you t is not equal to -2. So we've got 3 things there that we need to just keep an eye on what we cancel out, so that we know what we have to list when we go through the domain. So now pulling out my highlighter, the thing about multiplying is that you basically put everything, when you multiply fractions, you multiply the tops together, multiply the bottoms together. So you can basically combine these into one fraction. And if you combine them in one fraction, then when you're simplifying, there is no such thing as left side, right side. It's just top and bottom that you can cancel out. So I have a t plus 2 that I can cancel out with a t plus 2 on the bottom, and a t plus 3 that I can cancel out with a t plus 3 on the bottom. And then nothing else cancels. So once you cancel, then you write what you have left over. So we have t minus 3 over t plus 3, t minus 2. And you could multiply out the denominator. I generally don't. I leave it like that because it's a lot easier grading-wise to see that you have everything that you need. Now, looking at what was canceled out, we canceled out a t plus 3, but because I still have a t plus 3 in the denominator, I don't have to worry about that from the domain. We also cancel out t plus 2, so we don't have that in the denominator, so that's the part that we need to indicate as far as our domain, and so that gave us the t not equal to negative 2. So this is our simplified and rational expression, and it's the result of the multiplying, and then we have to specify that t cannot equal negative 2. Okay, example 2. Now this one's division. So the first step is to take the reciprocal and turn it into multiplication. So the first fraction stays the same. That's r over r minus 1. And then we get multiplication. And then I take the reciprocal, r squared minus 1 over r squared. So now that I've turned this into multiplication, now I can factor, find the domain, do all that. So the r, there's nothing to factor with r, there's nothing to factor with r minus 1, so that fraction remains the same. R squared minus 1 is a difference of 2 squares, so that's r minus 1, r plus 1, and then r squared. So looking at the domain, we're looking at r minus 1 not equal to 0, which gives us r cannot equal 1. Or we're looking at r squared cannot equal 0, which is the same as r not being 0, because if r is 0, 0 squared is 0. Okay, so now canceling wise, I can cancel out the r minus 1 with an r minus 1. I also have an r and an r squared. We're going to use the rules of simplifying exponential expressions with that. So the r on top has an exponent of 1. So when we simplify, we subtract exponents. 1 minus 2 is negative 1. So that's r to the negative 1. And then r plus 1. So I'm going to just get a different color here. So that r and the r squared, that's how I got the r to the negative 1. I don't know if you guys can hear my phone exploding. I'm going to put that on silent because that's getting annoying. Okay. So now I have a negative exponent. I just want to rewrite that so that it's in the denominator now, because that's how I get a positive exponent. So that gives us r plus 1 over r. The alternate way to do that, rather than doing the subtraction of exponents, is to actually cross things out and say, okay, I have an r in the top, I have an r in the bottom. If I remove an r from each, I'm left with another r in the denominator. So that's an alternate method, but it's really easy to make a mistake and get lost when things disappear. So I recommend doing the route where you subtract the exponents. Okay, so now that we have simplified, I do want to make it clear that we cannot cancel out the r on the top with r in the bottom, because you can only cancel things out if they are multiplied together. We have r plus 1. Those are not multiplied together, those are added. So those are considered grouped together, so we cannot cancel out the r's. You can't go any further than that. Now looking at our domain, r minus 1 got canceled out, so the r not equal to 1 needs to be listed. But we don't have to worry about the r not equal to 0, because we still get that with the r in the denominator. Okay, Example 3. Now this is an example of a complex fraction because we actually have a fraction within a fraction. So this vertical bar, the big one that we have, that is division. Because a fraction is the same thing as division. It's just another way of writing division. So we can rewrite this as x over 2 minus 1. I'm going to put parentheses around that to indicate it's that whole thing, divided by x minus 2. So when I write it that way, we don't actually have rational expressions because we don't actually have a fraction, really. We have one with the x over 2, but 2 is not a variable, so it's not really considered rational. However, this problem started out rational because it has a fraction with a variable in the denominator. So we can still consider this as we're dividing with a rational expression. And we're actually going to use the same sort of method you would use when you were adding and subtracting rational expressions here in order to simplify. And we're going to do that with the, changing colors, the x over 2 minus 1. Because we want to combine that to one fraction, which means we need to get a common denominator. So our denominator is 2, and that minus 1 I can make have a denominator of 2 by turning it into 2 over 2. So that way they have the same denominator. 2 divided by 2 is still 1. So when we add or subtract, we need to have a common denominator, and then once you have that common denominator, you combine the top together, and then you put it over your denominator. So we have x over 2 over 2. And then I've got and I'm going to turn the x minus 2 into a fraction by making it over 1. That was a terrible x. Okay, so now I want to turn the division into multiplication, and I do that by flipping the second fraction. So that's a 1 over x minus 2. And now we're back to multiplying rational expressions because now I do have a variable in the denominator. So before I do anything, I need to find the domain. And you always do the domain after you've turned it into multiplication. So I didn't really make that clear in the steps. I have that in order in the steps, but finding the domain has to be after you flip it into multiplication. Otherwise, your domain will be incorrect. So our domain here, I have 2 in one of the denominators. That doesn't matter. So I have x minus 2. That cannot be 0, which means x cannot be 2. So we're going to just keep that in mind here. So now, highlighter, I can cancel out. I have an x minus 2 and an x minus 2. So I can cancel those out. And that actually just leaves me with 1 over 2. Oh, I want to keep the colors. I'm going to turn that back to red. So that gives me 1 over 2. And then I canceled out the x minus 2, so I have to put that back in as the domain, and that was what the x not equal 2 came from. So our answer is 1 over 2, and we have to keep in mind that x is not allowed to be 2 because it can't be 2 in the original. All right, example 4 here. This is another complex fraction. And so you pick the middle fraction bar to be the main one. Usually we try to make it bigger than the other, some way to make it obvious. So that's going to be the point of the division. So this is really x squared minus 1 over x divided by x minus 1 cubed over x. So once you've rewritten that, then you want to flip and multiply. So the first fraction remains the same, x squared minus 1 over x. Then we have multiplication, and then we flip. X over x minus 1 cubed. Now it's the domain step. So I have x cannot equal 0 from the first fraction. The second fraction All we care about is what's in the cubed root, or the cube. The cube doesn't actually matter if it's odd. If it's even, that would mean that that part will never be 0 unless, well, it could be 0 if the inside's 0. Because if I have 1 minus 1 and then a squared, that's still 0. So yeah, all it matters is what's actually underneath that exponent. So that's going to be the x minus 1. And so that's not allowed to be 0, which means that x can't be equal to 1, because 1 minus 1 is 0, you're cubing 0, dividing by 0, not allowed. Now, before I start canceling out, I do want to factor that x squared minus 1. Now notice that I did the domain before I factored that part, and that's because the domain only depends on the denominator. So if the denominator is already factored, I can do that before factoring the rest. So just as a side note, because my denominator is already factored, I could go to the domain immediately. So back to the factoring, x squared minus 1 is a difference of 2 squares, so that's x plus 1, x minus 1. Then I have over x times x over x minus 1 cubed. So now I can cancel out the x's because there's one on top and one on the bottom. And then if I look at the x minus 1's, I can cancel one of those out, but the x minus 1 cubed means that there's actually 3 of them. So what you could do is rewrite that 3 times, or what you could do is cross out the exponent to indicate that you removed 1 by making it 2. But that usually is confusing. You can lose that 2 if you're not color coding, and you can get kind of lost. So that's why I do the subtraction of the exponents, which is the same thing that I did with the r's. So I have x plus 1 left on top, and then for the x minus 1, it's the top exponent minus the bottom. So if we don't worry about the green, that's 1 minus 3. So that would be negative 2. And then you want to flip that so that you have a positive exponent, and that gives you x minus 1 squared, which matches with what I wrote in the green. And I forgot I do have to put my domain before I box it. So we canceled out the x's, so I have to put that part of the domain that x cannot equal 0. We also canceled out an x minus 1, but there's still 2 left, so I don't have to worry about writing that part of the domain.